Alrighty. So let's start here. What do you guys notice about the theme of all these pictures on here? You see over here we have a bisector, we have a bicycle, a bimodal distribution, a biathlete, binoculars, bilingual, bifocals, bicentennial, biceps, and binary numbers. So you should be thinking that the theme here is 2. So next up, a binomial distribution. So what exactly is a binomial distribution? It's a distribution where each event only has 2 possible outcomes. So if you think about it, if you flip a coin, you can either get heads or tails. If you take a true or false test, you either write true or false. If you're getting a flu shot, you either get the shot or you don't get the shot. In class, you either pass a class or you fail a class. You might also have a phone or you don't have a phone. So anywhere where there has 2 possible outcomes, that's a binomial distribution. So at this point, you should be able to have your notes out. This looks like this sheet here. It says notes on binomial distribution. So take a second to pull that out, please. So the properties of a binomial experiment. So every time you get a binomial experiment, you want to check for bins. So that's B-I-N-S. The first part is the B, so that's whether or not it's binary. Every trial has to have only 2 outcomes, a success, which we represent as P, or a failure, which we represent as Q. If it does not have 2 outcomes, it's automatically not a binomial experiment. The next one is I, so that's for independence. Every trial has to be independent of each other. So that means no trial can have an effect on either the next trial or the previous trial. Then we have N. N is the set number of trials. So when you're going to do an experiment, you know you're going to do it like 50 times. Or if you're going through a card deck, you're going through 52 cards. And then S is the success. So for each individual trial, the probability of success has to be the same. It means every single time you have to have the same chance that you could be successful. So let's think back real fast to the ESP lab you just did. And let's check bins. So for B, binary, there's 2 options. You either have the 6th sense or you don't have the 6th sense. For I represents the independent. So if you remember, when you were going through this lab, you wouldn't tell the person if they were right or wrong. This keeps it independent, so they're not tempted to say a certain suit the next time. And then N, how many trials did you guys do? Well, you went through an entire deck of cards, so that was 52, so N equals 52 trials. And lastly, success. If we know that there's 4 suits, then what's your percent chance of getting them correct? Well, that's 25% chance each time. So let's go ahead and take a look at another example. Genetics say that children receive genes from each of their parents independently. Each child of a particular pair has probability 0.25 of having type O blood. Suppose these parents have 5 children. Let X be the number of children with type O blood. So this one is not in your notes or anything, it's just another example I want to walk through. So for B, either you have type O blood or you don't have type O blood. Those are your only 2 possible outcomes. Then we move to I, independence. Well, children inherit genes determining blood type independently from each of their parents. Then N. There's a fixed number of trials. For here, that's 5 children because we are supposing that the parents have 5 children. And lastly, up in the paragraph up top, it told us that each one has a 0.25 probability, or in other words, each child has a 25% chance success rate. Let's take a look at one more. So say we shuffle a deck of cards. We turn over the top card, we put the card back into the deck, and then shuffle again. We want to repeat this process until you get an ace. Let W equal the number of cards required. So we start with B. Either you get an ace or you don't get an ace. If you don't get an ace, you keep going until you get one. Independence. Yes, because if you remember, when you replace a card, it's like you start fresh like nothing ever happened. So that's obviously independent. And then we get to N. So here, the number of trials is not set in stone, because think about it. You could either get an ace your first card and be done, or you could keep going several times until you actually get an ace. So you can't say that you have to do this like 3 times or 5 times, because you don't know when you're going to get the ace. So when you get to S, you don't have to keep looking at this, because you already know that it fails in the N portion, so automatically you're done. It's not a binomial distribution. So now I'd like you to try the worksheet that has the 6 practice problems on it. So that one looks like this. Are the situations bimodal? So go ahead and go through. Some of these may not be bimodal. So remember, once you get to one of the letters and you notice that it doesn't fit that criteria, it is automatically wrong and is not bimodal. So go ahead and take some time to work on that worksheet, please. And that's it for today. When you're done, you can work on your project, please.